What is OSI model? The OSI model, or Open System Interconnection Model, is used to understand how networks or systems operate. OSI model is commonly used to specify and describe computer communication protocol. This layer is to establish a connection between nodes and layers, one for sending and other for receiving. Data link layer has two sub-layers, which one is data link control and media access control. Data link layer is responsible for designing and communication between two contiguous nodes. Data link layer is responsible for converting data stream to signal bit by bit and to send that over the underlying hardware.
So, good morning, Mom. Here I am to present our review of related literature in local. Our case study is entitled Data Link Protocol. So, RRL is the study in the past years. It is also found in internet, in books, journals, and newspaper. So, here I am to present our RRL and local region. So, there are 5 persons we search in internet, which is this following. According to Chorus, GF, and Ross KW 2017, they mentioned that when the data is transmitted across the network link, there is high chance of the signals in the network link being interfered in distortion, attenuation, and electromagnetic wave. According also to Chorus, GF, and Ross KW 2017, the parity checking can be visualized in different scheme. In this method, the error is detected if a single bit can be changed in data. According to Pramon Pandaya 2013, data link protocol has 2 sublayers, which is the logical control and the MAC. The logical control is responsible for flows and errors, while the MAC specifies how the nodes accesses the media. According also to Herman Demier 2012, some data link protocols offer capabilities to save energy. According also to Herman Demier 2012, some data link protocols offer the capabilities to save energy. A lot of energy can be used in transmission data, but also in receiving, and even for just sensing in a wireless channel. Last but not the least is, according to Derek Rountree 2011, the data link layer in the OSI model actually consists of 2 sublayers, which is the MAC and the logical control. The MAC sublayers controls the device interaction, while the logical sublayers deals with addressing and multiplexing. That's all for today. Thank you for watching and listening. And thank you, Mom, for your patience to teach and to give also your idea about this study. And we also thanks God that we are finished this study this year 2019-2020. So just keep safe always. God bless.
Good day, ma'am. I'm here today to present our review of related literature in international. The title of the case study is all about the data link protocol. RRL, this is the study of the past years. let's start the review of related literature. The first is, according to Strata Martin, year 2010, proposed the generic partial dynamic reconfiguration of controlling for the fault tolerant to design based on FPGA. FP, FPGA means this is the failed programmable array, a gate array. A big advantage of using these purposes is the one can apply the BDR together with other FT methodology effectively. So the second researcher that found the internet is, according to Tahichem, year 2010, presented the fault-tolerant data storage in the wireless sensor network. Each node performed the multiple roles such as the sensor, router, and storage. The data from an storage or the environment and does not only transfer the data to destination such as scenes but also stores the data in buffer. Therefore, a single one-node failure can cause the malfunction of various facilities of a WSN. This is the wireless sensor network. The data can spite of node failures to consume the reasonable energy. And the third researcher that found the internet is the Zanole or SM Zanole year 2010. Proposed the design and implementation of fault diagnosis system of recompression of process, integrated in the gasification of combining cycle of the section refinement plant of the use of the process to connect the other data in the other country or the other place. The fourth researcher that found in the internet is, according to Taurog et al. Year 2010, proposed the problem of multiple sensor held distinction and isolation using the principal component analysis. The instruction residuals are to use for the multiple variable reconstruction. For the base, the approach leads to explosion of the reconstruction for the combination, and therefore instead of considering all the subset of faulty variables, it determines the ensemble multiple in the moving in the isolation. And the five researcher found in the internet is the Marcela Siskova in year 2012. It proposed of the versification of fault tolerance methodologies of the fault tolerant for the system design. It widely accepted that they cannot be fault-free. The issue is the reliability makes use of the fault tolerant in the system design. This approach to guarantees at least limited the functionality of a hardware system even when there is an unanticipated fault in part of the any system.
According to Zuan Sumauria, Vikas Kumar Nayak, Dr. Inaugurao in the year 2014, they briefly explain about the data link layer and its protocol. Data link layer categorized in two parts, media access control and data link control layer. They work on data link control protocol, which contains 6 protocols, 2 for noiseless channels, Autopia and stop and wait, and 4 for noisy channels, par, stop and wait, go back and selective repeat. Utopia is simple, but it has the problem of flooding. Stop and wait protocol is easy to implement, but is not efficient because it needs an error-free communication channel, which is not possible in present scenario. PAR was easy to implement and it worked very reliably. It was a good trade-off between the ease of implementation and those loss in bandwidth. The number of frames retransmitted. Sliding window protocols have bidirectional and network model. It is of three types. First is 1-bit sliding window having some characteristics like stop and wait protocol. Second is go back end protocol required more input in terms of implementation due to buffer maintenance and keeping sender and receiver in synchronization. This protocol is not efficient due to the large number of frames retransmission. This protocol is not efficient due to the large number of frames retransmission. Whenever any frame is lost, instead of retransmitting that frame is retransmit all subsequent frames, and it also waits bandwidth. And third is selective repeat. It is little improvement over go back end and produce for better results in terms of the number of frames retransmission. It transmits only one frame instead of entire series, but there is no efficient manner of frame retransmission. In real-time application like video conferencing and live telecast, it creates the problem of synchronization. This problem is overcome by the protocol 7. In this protocol, we have priority on the NAC in which we are retransmitting the frame according to minimum sequence number of NAC. So protocol 7 gives optimum performance than protocol 6.
Geographically span. A system of interconnectedness computer and computerized peripherals such as printers is called computer network. This interconnection among computers facilitates information sharing among them. Computers may connect to each other by either wired or wireless media. Components of a network can be connected to each other differently in some fashion. By connectedness, we mean either by logically, physically, or both ways. Network can be seen everywhere. It's either in devices, buildings, and others.
Classification of data link protocols. Data link layer protocols are classified as LAN protocols, WAN protocols or protocols that can be used for both LANs and WANs. LAN protocols are distinguished by their capability to efficiently deliver data over shorter distance, such as few hundred feet, through various mediums such as copper cabling. Different protocols exist for different purposes and exist in different layers of the Open System Interconnect or OSI model. Typically, when using the word LAN to describe a protocol, the intent is to describe lower level or physical layer. Some of the most common LAN protocols: Ethernet, Token Ring, and Fiber Distributed Data Interface or FDDI. Ethernet is far the most common type of LAN protocol. It is found in homes and offices throughout the world and is recognizable by its common CATs. 5. Copper cable medium. It uses a switch or hub to which all systems connect to exchange data. Token ring is an older LAN technology that is not prevalent anymore. The basic premise of token ring is a single token is passed from system to system or through a hub, and only the intended recipient reads token. FDDI defines how LAN traffic is transmitted over fiber cabling. Fiber cabling is used when longer distances, usually between floors or buildings, are required, or where heightened security is required.
We will talk about the architecture of data link layer protocols. Data link layer protocols handles a job for gathering bits data for transmission packets. And it will also make sure that every transmission packets will get from one end to another. In addition, recognizing that physical layer transmission sometimes introduces errors. The data link layer handles error detection and sometimes correction. Physical layer protocols are classified as LAN protocols or local area protocols, and also WAN protocols, and we call it wide area protocols. Protocols that can be used for both LANs and WANs. Data link layer protocols that are reliant on a specific layer may be limited to the transmission medium involved, but in some cases, data link layer protocols can be ported to very different mediums. If there is a layer that stimulates the original medium the protocol was intended for, or if the protocol supports hardware independent upper the data link functionality. Data link layer protocols are implemented in system software layer. The data link layer is responsible for receiving data bits from the physical layer and formatting these bits into groups, called the data link frames. Different data link standards have varying data link frame formats and definitions, but in general, this layer reads the bit fields of these frames to ensure that entire frames are received, that these frames are error-free, and that the frame is meant for this device by using the physical address retrieved from the networking hardware on the device, and where this frame came from. If the data is meant to the device, then all the data link layer headers are stripped from the frame, and the remaining data field, called the datagram, is passed up to the networking layer. The same header fields are appended to the data coming down from upper layers by the data link layer, and then the full data link frame is passed to the physical layer for transmission. The data link layer provides the application layer with send and request data with reply, and send data with acknowledge communication services. For the former, the master issues a command or sends data to the slave and receives a reply within a defined time span. This reply either consists of acknowledgement or sometimes it is a requested data. In the sent data with no acknowledge, the data are sent a whole group of slaves. This permits event control the synchronization where all the slaves set their outputs stimulously or update their input data simultaneously. A master-controlled bus assignment for slave replies is not possible in this case, so that the SDN telegrams remain acknowledged. The access of the application to these basic forms of communication as well as the various data link service based on them as is granted via so-called service access points, which are used by the higher layers. The MAC protocol in a wireless multi-tap self-organizing sensor network should achieve two goals. The first is the creation of the network infrastructure. Since thousands of sensor nodes are densely scattered in a sensor field, MAC must establish communication links of data transfer. These forms of basic infrastructure needed wireless hop-to-hop and gives a sensor network self-organizing ability. The second object is to fairly and efficiently share communication resources between sensor nodes. Since the environment is noisy, the sensor nodes can be mobile. The MAC protocol must be power aware and be able to we'll be able to minimize collision with neighbors' broadcast. Here example of architectural design of a data link layer protocols. Here in this picture, it shows a LAN and WAN with a wireless and wired with a different parts of it. Every wireless has a part of data and protocols which connected each other and also with the wired. Same as LAN and WAN has a wireless and wired, and each of them has a part. Every part of it consists of different data shown in the picture. Both LAN and WAN have a different type of data and parts. Like in the LAN, it has a snap, a MAC, and also a Bluetooth. In the wireless, in wired, it also have the different part of it from the wireless. And also both of them have the different function of data link layer protocol. These are the architecture of data link layer protocols. That's all my report. Thank you.
CSMA and collision detection. In CSMA collision detection, the device monitors the media for the presence of a data signal. If a data signal is absent, indicating that the media is free, the device transmits the data. If signals are then detected that show another device has transmitting at the same time, all devices stop sending and try again later. Traditional forms of Ethernet use method. CSMA or collision avoidance. In CSMA collision avoidance, the device examines the media for the presence of a data signal. If the media is free, the device sends the notification across the media of its intent to use it. The device then sends the data. This method is used by 802.11 wireless network technology. Media access control for non-shared media. Media access control protocols for non-shared media require little or no control before placing frames onto the media. These protocols have simpler rules and procedures for media access control. Such is the case of point-to-point topologies. In point-to-point topologies, the media interconnects just two nodes. In this arrangement, the nodes do not have to share the media with the host or determine if a frame is destined for that node. Therefore, data link layer protocols have little to do for controlling non-shared media access. Full duplex and half duplex. In point-to-point connection, the data link layer has to consider whether the communication is half duplex and full duplex. Half duplex communication means that the device can both transmit and receive on the media but cannot do so stimulously. Ethernet has established arbitration rules for resolving conflicts arising from instance when more than one station attempts to transmit at the same time. In duplex communication, full duplex communication, both devices can transmit and receive on the media at the same time. The data link layer, the details of a specific media access control techniques can only be examined by studying a specific protocol. Media access control, addressing and framing data. Data link layer protocols, the frame. Remember that also there are many different data link protocols that describe data link layer frames. Each frames type has three basic. Number one is header, two data end, number three and trailer. All data link layer protocols is encapsulate the layer 3 PDO within the data field of the frame. However, the structure of the frame and the fields contained in the header and trailer vary accordingly to the protocol. The data link layer protocol describes the feature requires of for the transport of packets across the different media. These features of the protocols are integrated into the encapsulation of the frame. When the frames arrive at its destination and the data link protocol takes the frame of the media, the framing information is read and discard. This is no one frame structure that meets the needs of all data transportation across not cost effective for wide area networks that cover large geographic area, cities or multiple cities. For example, the cost of the long distance physical links and the technology used to carry the signal over this distance typically result in a lower bandwidth capacity. Difference in bandwidth normally result as the use of the different protocols for LANs and WANs. Ethernet protocols for LANs. Ethernet is a family of network technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet standards defines both the layer 2 protocols and the layer 1 technologies. Ethernet is the most widely used LAN technologies and support data bandwidths of 10, 100, 1000 or 10,000 Mbps. The basic frames format and the IEE sublayers of OIC layers 1 and 2 remain constant across all forms of Ethernet. However, the methods for detecting and placing data on the media vary with different implementation. Ethernet provides acknowledged connectionless service over a shared media using CSMA or CD as the media access methods. Shared media requires that the Ethernet packet's header use a data link layer address to identify the source and destination nodes. As with most LAN protocols, this address is referred to as the MAC address of the node. An Ethernet MAC address is 48 bits and it's generally represent an hexadecimal format. The Ethernet frame has many fields as shown. At the data link layer, the frame structure is nearly identical for all speed of Ethernet. However, at the physical layer, the different version of Ethernet place the bits into the media differently. Ethernet 2 is the Ethernet frame format used in TCP or IP network. Ethernet protocol are common data link layer protocols for LANs. Primarily used to Synchronization also contains as delimiter to mark the end of the timing information. Destination address, 48-bit MAC address for the destination nodes. Source address, 48-bit MAC address for the source node. Type value to indicate which upper layer protocol will receive the data after the Ethernet process is data or payload. This is the PDU typical on IPv4 packets that is to be transferred over the media. Frame check sequence or FCS, a value used to check for damaged frames. Point-to-point protocol for WANs. Point-to-point protocol or PPP is a protocol used to deliver frames between two nodes. Unlike many data link layer protocols that are defined by electrical engineering organization, the PPP standard is defined by RFC. PPP was developed as a WANs protocol and remain the protocol of choice to implement many serial WANs. PPP can be used on various physical media, including connection. PPP uses a layered architecture to accommodate the different types of media. PPP established logical connection called session between two nodes. The PPP session has the underlying physical media from the upper PPP control. This session also provides PPP with a method for encapsulating multiple protocols over a point-to-point link. Each protocol encapsulated over the link establishes its own PPP session. Point-to-point protocol, a common data link protocol for WANs. Flag, a single byte that indicates the beginning or end of the frame. The flag fields consist of the binary sequence like 0, 1, 1, 1, 1, 1, 0. Address, a single
Error detection and correction technique. Error detection allow detecting such as error, where error correction enable reconstruction of the original data in many cases. One bit event parity refers to parity checking made in asynchronous communication system in which an extra bit called a parity bit set to 0 if there is an even number of 1 bit in a 1 byte data item. Internet checksum technique used to verify the integrity of a life of data transfer. Cyclic redundancy check, an error detecting code commonly used in digital network and storage device to detect accidental change to raw data. Multiple access protocol. This is a dedicated link between the sender and the receiver, then the data link control layer is sufficient. Multiple access protocol used to coordinate access to the link nodes, can regulate their transmission into the shared broadcast channel by using multiple access protocol. MAC protocol, 3 broad classes. Channel partitioning, access to channel and rounds. Random access, 2 or more transmitting nodes collision. Taking turns, request to send clear to send message. Media access control techniques, a network data transfer policy that determine how data is transmitted between two computer terminal through a network cable. Other attack. There are other attacks such as two-layer
base broadcasting, and denial of service. Base broadcast. The attacker sends spoofed ERP replies to the host on the network. Denial of service. An intrusive internet attack made to take down the target website or slow down by flooding the internet. Port stealing. A man-in-the-middle attack where a LAN switch makes attempts to intercept packets that are meant to go to another host by stealing from the internet from the switch. DHCP attack. An attack that targets DHCP server whereby forget DHCP requests are crafted by an attacker with the intent of exhausting all available IP address that can be allocated by DHCP server. ERP spoofing. In computer networking, ERP spoofing or ERP poison routing, a technique by which an attacker sends address resolution protocol message into local area network. Backloading, a type of network attack where an attacker is connected to a switch port floods the switch interface with very large number of Ethernet frames with different space source MAC address.
Different cabling. In this section, you will learn about the network protocols that can be utilized at the data link layer of the OSI model. These protocols include token ring, FDDI, and Internet. Internet data link protocol are broken Internet data link protocol are broken out into addressing and framing standard. Token ring. Token ring is a LAN protocol that utilizes a token passing media access technology in a physical ring or physical topology, which is create a logical ring topology. So let's talk about token ring. A token ring LAN can run at either 4 Mbps or 16 Mbps. Each device must be configured for the same speed. Otherwise, the token passing does not work at all. Overall, although this protocol provides a collision-free network, it is also more expensive to implement than Internet. This is a major reason why Internet is the most popular data link layer protocol. Making token ring a rather distant second. The second one, let's talk about FDDI or Fiber Distributed Data Interface. FDDI is a LAN protocol that utilizes a token passing media access method on a dual ring topology. This protocol was created by American National Standard Institute or ASES with the ASES X3T9.5 specification. Data transmission occurs on fiber optic cables at the rate of 100 Mbps. FDDI was developed to run data across the network backbone of the large company. Dual ring is configured for FDDI to provide redundancy and fault tolerance. Also, because it runs over fiber, it is not susceptible to EMI like other option media. FDDI use method called beaconing to signal when a failure is detected on the network. Beaconing enables a device to send a signal informing to other device on the LAN that passing talking has stopped. The beacon travels around lobes from one device to the next until it reaches the last device in that ring. To troubleshoot, the network administration can provide beacon at the last device. And next, check connection between that device and the next connected device of FDDI network. Like token ring, FDDI is costly to implement, which is a disadvantage when designing a small network. The third one, so let's talk about internet. Internet use an access method called CSMA or CD, or carrier sense multiple access or collision detection. This is a system when each computer listens to the cable before sending anything through the network. If the network is clear, the computer will transmit. If some other nodes is already transmitting on the cable, the computer will wait and try again when the line is clear. Sometimes, two computers attempt to transmit at the same instant. When this happens, a collision occurs. Each computer then back off and wait a random amount of time before attempting to retransmit. With this access method, it is normal to have collisions. However, the delay caused by collision and retransmitting is very small and does not normally affect the speed of transmission to the network.
Issues in data link layer. The first one is framing. Framing is a translation of physical layers low bits into larger aggregate 90 or discrete units called frame. Here, beginning and end of the data are marked to recognize the frame and used in synchronization. Here, the receiver must know when the data begins and when it ends. Also, the receiver should be able to distinguish between each bit in the frame of the data. The next one is flow control. Flow control refers to the mechanism that makes sure that the sending station cannot overwhelm the receiving station. For example, it also prevents the buffer overflow. For example, the sliding window. The next one is error control. All transmission media has potential to introduction of error. Error control mechanism can detect as well as correct errors. The next one is link configuration control. Link topology. The physical arrangement of the connection between the devices. The last one is link duplexity. The first one is simplex. It can only transmit to the other. The next one is half duplex. The both devices can transmit to each other, but not simultaneously. And the last one is full duplex. The both devices can transmit simultaneously.
So we're here at the last part of chapter 3, which is the challenges and solution. So the first one is that check the operational status and the error rates on the network device interface. So this is the Cisco iOS shows commands such as the show interface command provide information on the physical and data link status of your device interface. So shows interface command also provides statistical on drops, collisions, broadcasts, resets, and ignores or errors. The second one is verify the correctness of interface configuration. On routes, misconfiguration of parameters such as media type, duplex, and encapsulation type of common errors. In contrast, on LAN, which ports incorrect speed, duplex native VLAN, WLAN rather, trunk, spanning tree, and channel settings are common errors. Loose cables and connection. This is the first one. If you have errors in your data link, first is you must check the broken or loosened cables or connection, because cable conditions such as open, kinks, crimp, sharp bends, and broken connection or adapter as well as loosened screws are common types of error. The last one or the part one is check for correct cable pin out. Some internet connection requires straight cable and other requires crossover cable. These are two types of cable that you must check in cable pinout if it's correct or not correct. Serial connection sometimes require a straight cable and other times require a rollover serial cable.
Good morning, ma'am. Good morning, classmate. Our case study is about data link protocol. And my part is chapter 4, concept and terms. The first term is protocol. Protocol is a set of rules or procedure for transmitting data between electronic devices, such as computer. The most important computer protocol is OSI, Open System Interconnection, a set of guidelines for implementing networking communication between computers. Next is adjacent network. Adjacent network means the physical, electrical, and electronic connection severally and integrally between all relevant elements of the adjacent network and the corresponding relevant element of the DPAT network. The use of a computer to represent the dynamic responses of one system by the behavior of another system module stimulate transmissions refers to the process of transferring data between two or more digital devices. Data is transmitted from one device to another in analogy or digital format. Basically, data transmissions enables devices or components within devices to speak to each other. Segment refers to the parts into which any object is or may be divided. For example, a text, string, or other data could be broken up into different segments that may or may not be related. And the last one is frame. Frame is a digital data transmission unit in computer networking and telecommunication. A frame typically includes frame synchronization, a feature consisting of a sequence of bits or symbols that indicate to the receiver the beginning and end of the payload data within the stream of symbols or bits it receives.